Hello, in this video we're going to see some examples dealing with combinations and maybe some dealing with permutation. So here we have how many ways can we select a committee of 3 from 10. So here the order does not matter, that's the first thing I have to think about. As long as I have 3 out of 10, as long as I have a group of 3, how many different groups of 3 can we make from 10? And here we don't care about who's first or second or third. If we care about first, second and third, that's permutation. But here we're dealing with combination. We could write it like this. 10, 3, which is 10 factorial divided by, remember this is the permutation, 10 minus 3 factorial. But because the order does not matter, and the order of 3 will be 3 factorial, so we divide by 3 factorial. So we use the formula straightforward. And so what we have is 10 factorial divided by 3 factorial times 7 factorial. And if we do everything in a calculator, we get 120. Another example here, we have how many ways can a committee of 2 women and 3 men be selected from a group of 5 different women and 6 different men. So right here, I need 2 women out of 5. So basically I have to take 2 out of 5, and then we have 3 men out of 6. So this is what we need. So how you do that? So now we just have to use multiplication principle. So what we have 5, 2, which is 10, and the 3 out of 6 we have 20. So the total number of ways selecting the committee is 10 times 20, which is 200. Another example here we have how many 5-card poker hands can be dealt from 52 card deck. So if you remember, a poker hand is 5, so basically the order does not matter. All what we need is a combination 5 out of 52. Remember, we could write it like this too sometimes, which is 52 factorial divided by 5 factorial times basically 47 factorial, which is 52 minus 5, which is a big number. You could put everything in a calculator and we might get. Now that's similar. How many poker hands contains card? All of the same suits. Now we have a little bit different scenario. So the same suit, how many we have in the suit? So we have 13 cards, right? In the suit. And poker hand, we are dealing with 5 cards, right? Because, so all of the same suits, meaning we have 4 suits, right? Which are the heart, the club, and so on, diamond. We have combination 5 out of 13, because we need to pick 5 from the 13 suit. But because we have 4 suits, we have 4 different ways of choosing the same suit. And the total become 5,148. The 13 because 13 in the suit, and 5 is the poker hand. Let's see the next example. How many ways can 3 athletes be selected winners from a group of 10 athletes who compete in an Olympic event? So again, even though we're talking about athletes, I did not mention anything who's going to be first, second and third. So this is a combination. We just need 3 out of 10, which is a combination 3 out of 10, which is 120. So here I mixed all different questions back and forth, so you could always stop the video and try the question before I answer it. For example, this one here, I have how many ways can a committee of 2 be chosen from 4 men and 3 women? So we have 4 men, 3 women, and it must include at least 1 man. Okay, so that's the key. We must include at least 1 man. So we need committee of 2 men from 4 men and 3 women. But at least 1 man in the group. What does it mean, at least 1 man? Meaning either 1 or 2 men in the group, in this committee. So if we choose, we could choose one man out of 4. Remember, we have 4 men and then 3 women. So we could choose one man from 4, and then, because we need a committee of 2, so the other one can be women. So we choose one man, one woman. Or, which always we do plus, the other choice we have is that, because it says either 1 or 2 men. So here is 1 man, because 1 man and 1 woman, because the group consists of 2. So the other one, it could be both of them are men. So I don't need any woman. So 0 out of 3, which is just 1. We don't need to write. So if we do everything here, we get 18 different groups. Another way to solve this is this way. So you can think about how many groups of 2, because the total we have is 7 total. 7 people. So we could, where is everybody? How many groups of 2 can we have out of 7? So it's 2 out of 7. And then we could subtract the group with 2 women, because, and we need at least 1 man. That means we have to remove, because we need to remove the groups with 2 women or no man, which is 2 out of 3, and also gonna give me 18. So here we have 2 different ways to solve the same problem. And let's see another example. How many distinct permutations? So already here we know this word permutation. That means I have to think of permutation. Can the character in the word Mississippi, how many, if we take Mississippi and move those letters around, how many different ways can we have these letters rearranged? So as you see here, the word Mississippi, we have 11 letters. 4 of them are S's, and 4 of them I's, and 2 P's. So we have to take that in consideration, because we do have 11 factorial. That's when we took all the letters and we rearranged them. But sometimes moving this I here with this I here doesn't make a different word. It's exactly the same. So we have to subtract that, and subtraction is the same as division. We have to take away the 4 factorial and 2 factorial and another 4 factorial. And this way we take care of all the other arrangement where I's are rearranged, or all those 4 S's being permutated. Let's see another example here. Quality control wants to test 25 microprocessor chip from 300 manufacturers. How many different batches of test chips are possible? So here we just need a group of 25 out of 300, which is 300 factorial divided by 25 factorial times 275 factorial. And this is a big number. We just leave it the way it is, or we could leave it as combination 25 out of 300. Another example here we have how many juries of 5 men and 7 women can be formed from a panel of 17 men and 23 women. Okay, so that's very simple. We need to pick 5 out of 17, and then we need to pick 7 out of 23. So we multiply them, and that's the answer. We leave it the way it is because it's a big number. Let's see this example here. So this example here, we are dealing with the following situations. A company personnel. We have 7 work in design, 14 in manufacturing, 7 in testing, 5 in sales, 2 in accounting, 3 in marketing. A committee of 6 people is to be formed to meet with upper management. So basically, if you look at the total number of people we have from this company, we have 7 plus 14 plus 4 plus 5 plus 2 plus 3. We have 35 people to choose from. But there is some restrictions. It says how many committees of 1 with 1 member from each department are possible. Well, this is straightforward. You have a combination. You could write it as 1 out of 7, 1 out of 14, 1 out of 4, 1 out of 5, 1 out of 2, and 1 out of 3. or basically right there you have 7 to choose from, times 14 times 4 times 5 times 2 times 3, which gives me 11,760. So this is a straightforward question. But here is some other restrictions. It says how many committees with no representative from accounting, and exactly one representative from marketing are possible. So here is where we want committee of 6, okay, but with no one accounting, 0 accounting and 1 marketing. So here is where we want committee of 6 with 0 accounting and 1 marketing. Okay, so we could think about it as to have exactly 1 marketing. We could say it's, since the marketing we have three of them, so here let's pick 1 from 3, and this guarantee 1 marketing, right? So here we need a committee of 6 with 0 accounting and 1 marketing. So to guarantee 1 marketing, we say we're going to pick 1 out of 3. So here we guarantee 1 marketing. Okay, and then we multiply it with 5 more, but with 0 accounting and 0 marketing. So since we have 35 people total, if we take away everybody that represents marketing and everyone that represents accounting, that will give me no marketing, no accounting. Marketing is already been accounted for right here, and here will give me no marketing, no accounting. And so this is how you answer this question. I hope you'll find this helpful. Thank you.